a lot. All right. How about Robbie Allen, guys? What a great North Carolina success story, huh? You know, the last time I was together with Robbie, we were having dinner with the Hungarian ambassador. For some reason, I can't remember. I don't know where Robbie went or if he remembers why. I remember two things from that, though. One is that the Hungarian ambassador to the United States has an amazing Bond villain name. It's like Dr. Laszlo Jabot or something like that. You can look him up and see him. He's like 6'4", bald-headed, so prove me wrong if you don't think he's really a Bond villain. I don't know, he's a really nice guy, actually. We had a great conversation. The second thing is Robbie sharing his success story here in North Carolina. And it really is compelling. And that, after all, it occurs to me sitting down there listening to him today, is really what this day is all about, right? It's about this community, this ecosystem, not just about making North Carolina relevant or competitive, but prosperous, right? We want to make, and I see a lot of good success stories out here today, but we want to make more. And it's going to take NC Tech, so thank you, NC Tech, for putting these sorts of things together, and for all of you who are supporting it. I can't think of any other way to do it unless, for example, Jim Goodnight woke up tomorrow and decided to do an ESOP and give stock to all the SAS employees and go public on Monday. It's not going to happen, so just accept it, people. I've accepted it. It's not going to happen, so we have to keep doing stuff like this. So I'm really happy to be here. Thanks again for inviting me to share some of my perspective. I do want to talk about, we have some very similar views about how important machine learning is, how weird it is, and how it's different from stuff we've done in the past, and I'm going to share some of that perspective with you today. This is my background. This is my street cred slide, my 27 years in the industry, all here in North Carolina, by the way, raising capital, usually having to get on a plane and go somewhere to get capital, but then working in computer gaming, as was mentioned earlier. I sold my last company to Lockheed Martin, spent 6 years there running a group called Virtual World Labs, where we had over 100 patent disclosures in the fields of VR, AR, and AI. And what I want to do with you here with our special time together over the next 20 minutes is talk about how I got religion on machine learning, why I left my ridiculously overpaid job at Lockheed Martin, where I was addicted to direct deposit, where I got paid every Friday. My mother-in-law still hasn't gotten over it, but my wife is still with me, so that's good. That's a good indicator. But I'm going to give you those perspectives. And hopefully by the end of it, all of you will have a similar perspective. What I learned this morning, though, is many of you already have the gospel, right? Can I get an amen? All right. How many of you already work for an organization that has a machine learning strategy? How many of you are leaving this conference to go back and start developing one? All right, so we're achieving our goal. And I'm going to try to do that with you today in my time with you. Give you at least $1 billion idea because you deserve it. And if I run out of time, there's some young ladies, I think, here wearing shirts like mine who have golden tickets to an event right after this, if you don't want to run right into traffic, at the 21C Museum Hotel, where we will go deep on machine learning and talk about it a little more in depth. Are there investors here? Any North Carolina investors with active funds? I didn't expect to see it. They're like unicorns, right, if you can find them. The one I'm aware of is David Gardner. If you can find David Gardner anywhere, give him your money if you're an investor, and encourage him all you can, because he's doing great stuff. But I've had to go out and find money from people like Joey Ito and Reid Hoffman, so I had to go all the way to Japan with Joey. I don't know if you saw him on 60 Minutes last week, or Reid Hoffman, the guy who founded LinkedIn, invested in my last fund. You can find him everywhere, it seems like, lately. But the last company that I just funded, I got with North Carolina Investment, and we have to keep working on that as well. So here's my big thesis statement, and that is, I think one of the most critical things, and the reason, again, I left my job at Lockheed, I think the most critical thing for the 21st century is for everybody, whether you're an individual, an organization, a state, a country, is to figure out where that balance is. The balance of, like, what should we be doing with human attention and effort, and notice that I discriminate between effort and attention, and what should we be turning over to machines? And by the way, the answer So that question is changing almost every month, and that's the challenge, right? You can't just say, oh, well, we answered that question last year, and we've organized around that. You have to keep looking at it, and I think there's a new job right there. Let's call it human resource officer in every organization. Continue to look at whatever your activity is and start answering that question. What do humans do? What should we be doing with machine intelligence? And by the way, do we develop that inside? Do we go out and find something we can integrate, or do we have to buy it from somebody else? So here's how I kind of got religion on this. I was at Lockheed. They gave us a call. These guys up in San Francisco at Microsoft Research Labs were working on this project called Natal. You guys remember this? How many of you have a Microsoft Connect in your home? Well, they just discontinued it, but that's not the point of this anyway. The cool thing was Alex Kipman, the guy who invented it, who's now working on the Microsoft HoloLens, called us at Lockheed and said, hey, we're looking for the best sensors in the world to put into this little device. Can you help us? So we flew out there, signed NDAs because it was all top secret, and worked with them on the sensors. But found out pretty quickly they already had that nailed. And what they were doing with machine learning was even more interesting. So this was 2009. And by the way, the other guy next to me is Jaron Lanier. He's a guy who coined the term virtual reality. I've been on stages like this with him going all the way back to 1993. So we're watching that little hype cycle go up and down, and we'll see if what's going to happen with it this time. That's another 1-hour talk. But what we ended up getting really fascinated by while we were there at Microsoft Research Labs is what they were doing with machine learning. See, they'd already shipped Xboxes all over the world. They had about 100 megabytes of available space, and they were just trying to teach this system what a living room was. Now, that's an easy thing for a human to understand, right? What's a table, what's a chair, what's a plant, cats, dogs, telling people apart. That's always been something that's pretty easy for people to do, but at that time still, in 2009, that was computationally very, very difficult. So the way they solved it is a supercomputer and then a massive set of examples. So the old AI, like when I was doing computer gaming, was around, a human would sit down and write the rigid logic for, a hierarchical behavior tree or something that tells a character how to react. And it's important to master that in gaming if you want to have convincing characters and convincing environments. This is a new thing, and that's my algorithm for it. I think Robbie had another way of describing it, but it's really just now instead of sitting down and writing that logic, where the old way is you wouldn't ask a computer to do anything unless a human understood it completely, then you sit down and tell the computer this is how you drive a car, or this is how you recognize a chair. The new thing is just massive sets of examples and let the machine learning system infer its own understanding and improve its own judgment. That was a revelation to me, and that was 2009, and to me, everything changed. Shortly after that, everything went dark. No, what's going on with the screen? There it is. Google bought DeepMind, and we started seeing other good examples of this, where instead of, again, trying to teach a system or just programming in the logic for how to play an Atari game, you let a machine learning system watch people play Atari. Very quickly, they can come up with their own rules, can play, and actually master the game and beat humans at that. Then 2 years ago, if you heard this bump in the night, that was the time when a machine learning system beat the #1 Go player in the world. That's significant because it took even guys like me and Robbie and others in the industry by surprise. Because we said, hey, it's one thing for a machine to beat a human at chess. That happened in 1997, and chess is a complex game. There's as many chess positions as there are stars in the galaxy or something like that. But there's as many positions in Go as there are atoms in the universe. So we thought it was going to be several decades out. Again, humans think in a linear way. Machine technologies work on the exponential curve. So that was really interesting. That happened 2 years ago now. And since then, something even deeper happened. And this is one thing that we're all paying very, very close attention to and are a little scared of, but not too much. This is this thing called generative adversarial networks. That's where you take a system, you don't even tell it what the rules of Go are, just let it play the previous version of itself, and very quickly, as you see in this chart, it gets up that sort of machine learning curve very quickly and masters it very quickly and then continues to improve sort of ad infinitum. Pay attention to that. We won't go too deep into it because I don't have enough time. If you want to go deeper, again, we'll be across the street, see a Tanjo girl, get a golden ticket. So this is one of the few, this is sort of a classic problem and one of the first things I worked on at Lockheed just to sort of set the tone for this. A classic problem, and I use this example of everybody recognize this, the last scene in Raiders of the Lost Ark. You have this incredibly potent artifact that's been given to a clerk, and that clerk is taking it and is putting it away in this warehouse where it's undiscoverable by human beings. It has a little tag on it that says, you know, Ark thingy. You can either save or destroy the planet, but it just says Ark thingy on it. Arnie Duncan at the Department of Education came to us at Lockheed and said, we have this great opportunity. We have a lot of information available in the federal government. We want to make it available to school teachers. Very simple thing, right? Think about the Smithsonian, the bowels of the Smithsonian with all this stuff that's been scanned in. They're trying to get everything digitized, and then human beings were in there trying to tag it all and say like what it is so you can put it into a system so it can be discovered. What we did then is build a system kind of like the way if you saw IBM Watson play Jeopardy, where it would look at something and say, I think this is a clicker made by Q, and if its confidence level is over a certain amount, it would go ahead and just tag it on its own. If it was below a certain level, then it would submit it to human experts, and those human experts would say, no, it's actually this thing. And the great thing about the powers of machine learning are that they can go through things like that very quickly, and once you update their database and give them a good example, they store that, they never forget it. That's really the main things, the superpowers that we're trying to put to work. So from that, first of all, we created a newsreader that we decided is going to learn all human knowledge. Way too ambitious, like most startups, right? We raised a couple $1 million and we just got a little heady, I think, and decided we're going to solve the semantic web problem. We're going to learn all human knowledge. We took the Dewey Decimal System as sort of the framework for it. Like, here's how you categorize human knowledge. Someone's already done that for us. And then we decided we're going to give it to university students, to millennials. And they're going to go in and just sort of help us improve knowledge. Guess what happened? Guess what they thought was important? University students. So pop culture. They didn't really refine my database and make my brain smarter. They decided that the most important thing in the world was pop culture. It was, what are the Kardashians doing? What is Kanye West thinking today? You know, that kind of thing. So we had to take that out behind the shed and shoot it. This is, you know, and the IBM guys, you guys have had the same experience, right? It wasn't just us. You guys tried to teach your Watson brain using the, what was it, Phaedra, the Urban Dictionary, right? So it started cussing in its responses, so they had to take theirs out behind the woodshed and shoot it. So we have to do that occasionally, but the one we have now is really nice, really good, and would love to talk to you further about it. And this is the other general idea. I talked about supervised learning where humans are then, you know, human experts are helping to curate that information. But very often, the most interesting thing we do with this new brain we've been training for the last 4 years is to actually give it just dump this sort of information into the top and then let it discover every hypothesis that it thinks might be true. That's why we call this the new scientific method. There's all kinds of really interesting things you can do with this capability alone. Again, I could probably spend an hour on this, or my CTO, Ken Lane, could spend several hours, there he is in the back there, on this very subject. You can find really interesting insights just by using this capability. I skipped over the fact that one of the things we did early on is we were at some conference and LexisNexis was there, and people were talking about, like, you know, if you could have your brain just learn the law, right? You have a $100 million company. So that got our attention. So we said, okay, give me a big data set. Where are my massive sets of examples? And we were able to find every single legal opinion in United States history, went back to our new brain that we had revived and resurrected after shooting the old one, and we just dumped all every single legal opinion ever rendered in United States history into the top. And within a week, that brain had created an entirely correlated sort of understanding of the law. Pretty amazing stuff. Now, we still haven't figured out what to do with that because it turns out that lawyers who've tried to use our system, it returns way too many examples for what they're trying to do. And I think LexisNexis, by the way, has this kind of nailed. So it's not something we're really doing right now, but it is very, very interesting. Another thing we did with an accounting firm, and I think some of you are here, you don't have to raise your hand, you can if you feel like it, but they were admiring a really interesting problem last year. There's a new set of revenue recognition rules that came out December 1st, 2017. Also lease recognition, I think. Accountants were running around the country having conferences saying, how do we prepare our clients for this? How do we prepare ourselves for these new rules that are coming out? We looked at that and our experience and said, that is a classic, awesome machine learning problem, right? So let's take the new rules, which is actually kind of the old AI, and let's take a massive set of examples of sales contracts. So we went to this firm and said, all right, give us a bunch of sales contracts we can train our brain on. And they actually named it Bebe or something like that. They gave the brain a name. At first, they gave us like 300 or 400 examples. And we said, maybe we weren't clear. We had to go show them this picture again. Or the other picture I was showing a second ago, like I think this one, and say, I need millions of examples. So we finally found, again, about 4 million contracts. And these were contracts that could be everything from a purchase order that someone had written out all the way to, let's say, a 100-page contract with warranties and disclaimers and performance clauses and milestones. Let it read through all that and, again, improve its understanding so now it can help human beings rapidly go through and read a large number of contracts and apply that judgment. So this is really powerful capability. And by the way, this is low-hanging fruit. This is the kind of thing any of you can do. If you see problems that are similar to this, where you've got to read a lot of stuff and render some kind of human judgment to it, think about like reimbursement codes in healthcare, items like that. You should be doing this immediately because this is truly a 10x or more kind of ROI that you can get from this. About 6 months ago, I met Daniel Pinto, who is the CEO of one of the investment bank for JP Morgan. And they were just beginning to wrestle with like their machine learning strategy and that sort of thing. This was not that long ago. And one of the problems they were looking at is every year, they were spending about 360,000 hours a year of New York lawyer time. How much is that, by the way? Anybody got a number? Say, let's call it $800. I should use 1,000 to round it up or something. But let's say it's a $300 million a year expense that they have just reviewing loan agreements, right? 4 months later, they now have a machine learning system that does that, automates that completely. New York lawyers are running out there like begging for money or something, I guess. I don't know what they're doing, poor guys and gals. But think about that. A one-time investment of, let's say it costs them $500,000 to implement that machine learning solution, and they now get a $240 million annuity from that one-time investment. This is an expense, by the way, that's built into their stock price and that all their competitors have, they're no longer ever going to have. So that's not a 10x, that's a 200x improvement in efficiency and direct ROI they got just from doing something very simple about just like what I was describing to you here. So my billion-dollar idea for you, by the way, is everybody should pool their money into a hedge fund. We should just invest in companies that are implementing machine learning right now who've not yet built their machine learning savings into their stock price. That's your billion-dollar idea. We can talk about it further. Everybody get your wallets out. And the last idea I have for you is this. And this is kind of arbitrary. Robbie was talking about his 2010 sort of watermark. For me, it was 2009 when I went to Microsoft Research Labs. But the old AI, again, was how we'd sit down and write that rigid logic into machines to tell them what to do. The next phase, the phase we're in right now, is where we can't find enough data scientists, right? It's about lots and lots. How do I get my data massaged into those data lakes that I can then turn over to the machine so that it can improve its judgment? But next, I think, is this next wave that's coming right now. It's about psychology. It's about human behavior. I think we just gave a Nobel Prize, didn't we, last year, to Richard Thaler in this field. What we're doing at Tanjo is we're out trying to find all those people who work in these behavioral sciences and get them close to us, because that's the next wave, is how do you build systems that are provably aligned with human values, and how do we understand human behavior better? It's been in the news a little bit lately. So we found a couple of folks like Dr. Jordan Louvier, Dr. Richard Carson, who's the head of the economics department at UCal San Diego, Tiago Ribeiro. These guys are all sort of disciples of Dan McFadden, who won the Nobel Prize in this field about 10 years ago. So we're happy to have them working with us. And this is the thing that we've learned. And I don't know if you saw, they turned me on to this book about a year ago. But in market, how many of you are in marketing? Like market research, that sort of thing? So in marketing today, we do focus groups, right? We do surveys, we do e-surveys. We ask people what they think. And the problem is, as you'll read in this book, everybody lies. And I'm going to give you a reading list, and I actually tweeted it out already, so you don't have to write this down. Just go to my Twitter feed, and you'll see the books that are required reading, I would say, for you. But that's really interesting. If you looked at Brexit and you looked at the election that we just had, you looked at the poll data, it predicted one outcome, right? But the data said something completely different. The data would have told us that Brexit was going to happen. It would have told us that Trump was being elected. So that's what we're focused on with the next set of things that we're building. And our background, again, at Lockheed Martin was building these large constructive simulations where if I'm modeling trying to model behavior for a country like Afghanistan or Haiti or something like that, I don't have 4 to 5 representative, segmentation models of the population of a country. I have millions and millions of agent models in these massive constructive simulations. I run all these sims against it, like, hey, what if I built schools for girls here? What if I improved the roads? What if I did this USAID activity? And it would predict and run not 8 examples, but 10 to the 8 experiments, and then show me the Monte Carlo distribution of outcomes and tell me what I should be doing. That's the world we come from. So I'm going to skip past this, but actually I'll say this really quickly because I'm running out of time, as I knew I would. But we just signed a deal with Nielsen, and before you start getting upset about privacy, the deal that we have with them is we're able to take data from 126 million households, turn that into a synthetic population, and using machine learning, a synthetic population of the United States that we then can use to get to the truth. What are our true values? What do people really care about? How do we help people design better products and build better relationships in the marketplace that are based on truth, not on poll data, and not on a lot of the other things that we're using today. So we're really excited about that. And the way we do this, by the way, just very quickly, is you take a machine learning system, for example, and you just let it read. If I can read everything, for example, Victor Hugo's ever written, everything written about Victor Hugo, I resurrected him about a year ago. I've talked to some of you about that before. First thing I could do is just go visit Victor every day and see what he's attracted to on the internet. What's he reading? What does he care about? What does he think about current events, right? We did that for a bunch of people, George Washington, Martin Luther King, all sorts of folks. And this gets really interesting in marketing when you go to the next phase, more like what Robbie's talking about, when now I can actually write my message. So if I'm the president of United Airlines and I've had a big PR issue, I could sit down and actually practice my message before I release it. He didn't have this tool, obviously, or he would not have said a lot of the things that he said. But you can actually write to these customers, or it could be your employees, could be anybody you've modeled, and practice, or in a safe practice environment, test these ideas, and you see them reacting in real time to what they think about the thing you're writing. And obviously the next step is being able to do natural language processing and actually speak directly to them, have them talk back to you without having to bother them at home or call them or actually have them fill out surveys where, by the way, we know they're lying, right? So these guys can't lie. Our personas cannot lie because they're based on data. They only represent the information that is used to build them. I just have this because the first natural language processing game we worked on was with science fiction writer Douglas Adams in 1997, quite a long time ago, and I just happened to see that the character we built for that looks a lot like this character from the movie Passengers that came out. And then lastly, about a year ago, my dad died. Of course, I had to, right? Being a technologist and having this capability, first thing I did was had a system read in or scan in all of his military records and personal letters. He wasn't on LinkedIn. He wasn't on Facebook. He had no Google footprint. So it was a challenge. But it's been oddly comforting to be able to go visit him every day, see what he thinks about what's going on, and at some point soon here, I'm going to be able to talk to him. I know it's a Black Mirror episode, and Ray Kurzweil's been talking about this so it's not an original idea, but it's interesting, and the capability is now here. All right, so again, I'm going to go ahead to my golden ticket thing here. If you want to go deeper, see one of these folks here. We're going to be over at the 21C Museum for hotel for a couple of hours, and we'll be talking more deeply about these things. And then here's your readers list. Well, it just popped out, but I did tweet it out. If you go to Metaversial, you'll see all the things that I think you should read, especially The Intention Economy by Doc Searle. All right, and thank you. Tip your waiters. See a Tanjo girl for a ticket, and thanks for your time.